Thank you to all of our panelists. The time has now come to open up the event for questions, comments, discussion, objections, and whatever people want to say. Yes. Please direct your question if you can to one or more of the specific panelists.
Sure. Well, thank you all for speaking. Full disclosure, I came in as a believer in climate change, and that hasn't shifted. I'm not a denier. But one thing that I think was kind of alluded to in the third half of the presentation, if you will, was the idea that these are all kind of very rational responses to what happened in the events of ClimateGate. But it's becoming more and more obvious that the people who are denying climate change are not rational people. So to what effect is it an effective means to kind of emphasize science as the main reason for a change in policy? I'm a believer in the science, but at this point, is it kind of like preaching to the choir? Like, the people who believe it will follow development of the science, and the people who don't are going to remain unconvinced. So is it time to start shifting to the economic benefits of preparing for climate change, or the national security benefits? And if the end is the same of switching to more renewable energy or lowering emissions or things like that, is science the best focus for making that happen at this point? Thank you.
I assume you're talking to me. I think you're absolutely right. I think that probably our best hope for the planet at this point is that we'll make the right decision for the wrong reasons. But that's just my guess. You guys may have other opinions.
I think I agree with one of your foci, but not necessarily the other one. And I'm an economist, so you might be surprised to hear that I don't think it's the economic benefits that worry. That paper on the right-hand side with the 6 burning embers for the reasons for the concern for the United States has 2 conclusions. One is that the United States will not discover dangerous anthropogenic interference with the climate system if all it does is worry about economic indicators of climate change. They will add them all up, and they will see some benefits and subtractors, and nothing really serious will attract very much attention. But there are 3 other reasons for concern in the global pictures, and a 4th for the United States that have to do with risks to unique and threatened systems, of extreme weather events, and the consequences calibrated in whatever is appropriate to have them calibrated. The change in the likelihood of abrupt climate change and accelerated class rate emissions and runaway greenhouse effect. And then the 6th one was, unlike the other 5, didn't come from the science, and it's not the science saying that we have the right answers, but we've identified what we think are some risks, and we're trying to make progress on those. But the national security ember comes from the national security community, and they are the only community in this country that has for centuries worried about the dark tales of probability distributions of what might happen. They do that for a living, and they practice that over and over and over again. And they are afraid that the dark tales of climate impacts, mostly distributed by distributions of extreme events, will cause national security, enhance national security risks around the world, and alter the way in which they have to distribute their assets. In response to humanitarian crises, migration across borders where people don't like each other, all sorts of things like that. So I don't know if that's focusing attention in Washington to do something about climate for the wrong reason. There was going to be a lot of social science and scientific investigation of the link of climate change to enhancing national security risks. But that community believes it wholeheartedly.
Yeah, there's someone who, if the previous questioner includes skeptics as well as deniers as irrational, I hope my question can make some sense. And I think calling people deniers who have questions really really is very unfortunate in terms of having a civilized debate. But I've thought about risk assessment my whole life. And two of my observations that I'd like whichever panelist comments on that they would like to comment on are that very often models work very well on an explanatory basis because they're fit until they do work on an explanatory basis. And that has nothing to do with their value as predictive models. And for instance, we know that's Freeman Dyce's main criticism of a lot of the climate science. And maybe you think he's irrational, but I don't think Freeman Dyson is irrational, and I don't think John Christie is irrational, and I don't think Richard Lindzen is irrational, and I don't think Michael Crichton is irrational. These are all people with very good scientific credentials who have real questions about the modeling that has been done and the conclusions that have been led to them. The second, an interrelated thing, because it gets to the validity of models and it gets to how we assess long-tail risks, is that we know very clearly that, in fact, when models appear the most accurate is when they extrapolate from very, very long-term trends. And unless we get the length of the trend right, we can very well mistake secular forces and cyclical forces. And it seems to me that those of us who are skeptics, like myself, on two levels. One, is the warming really secular in nature, and more important, how much of it is anthropogenic? Because I think that's the real question. If it's not anthropogenic, then the risk, the things we do to mitigate the risk are very different than it's anthropogenic. But sort of, I've thought about risk my whole life in a lot of different ways, and those two questions really bother me about a lot of the projection that we make from our knowledge of the very recent past, which I define as 300 or 400 years, into the future for the next 300 or 400 years in terms of what's going to happen to Himalayan glaciers.
I'll take a first crack at that. So in terms of the models, I mean, you were saying looking at the trends from models, but the climate models at least are not based on past and future data. They're based on first principles. Our understanding of how the atmospheric circulation works, how it interacts with ocean circulation, what carbon does. So the drawback to it is that we don't understand the processes well enough to do that really well, but they keep getting better and better. But it isn't an extrapolation of it happened sometime in the past and now it's going to happen in the future. It's basic physics first principles.
Professor Dyson would disagree with you. He knows the people, for instance, in Princeton. He said they then fit the models to the data.
Well, I've worked at GISS, and they don't fit the models to the data there. So I don't know what he's saying. You use, when you have data and you look at your model, and for example, looking at climate data from the past, it's the one where you can look at the model and you look at it and you say, well, this doesn't make any sense. So suggests that maybe there's something wrong with the model. So then you go out and try to get more data and understand what part of the physical world you don't have right in your model. So if you think that is adjusting your model results, you're right, but I don't think that's adjusting model results when you try to understand the basic processes better.
If I could try to, I'm not a climate modeler, but I know a lot of them. Fitting to the past is certainly, to an economist, it means something different than to a climate scientist. They try to calibrate. They do backcasting experiments and then try to move forward. It is based, to the best of their knowledge, on process. They keep adding things. They take things out. They, for example, in the fourth assessment report, took out all sea level rise except for thermal expansion because they could not explain what was going on in the polar ice sheets. They knew that their previous understanding wasn't describing what was going on, and they didn't have an alternative explanation. If they didn't have an explanation, they couldn't calibrate it, and if they didn't have either of those, they couldn't project forward what it was going to be, and they took those numbers out. For that part of the climate science, that's a perfectly appropriate thing to do. For people who want to worry about adaptation, say in the city of New York, it's not very helpful because you're going to make very long-term investment decisions on infrastructure and protection decisions and things like that. And if all you have is thermal expansion, when you think about what a storm surge is going to look like in Manhattan, you're underestimating potentially the dark tail of what could be a very uncomfortable result. So I think two things in response to your honest skepticism, and then I'll make a third, which maybe we should do offline. But the first one is that honest skeptics like Dick Lindzen participate in this game, engage in a significant part of the conversation in Academy panels and things like that. But even Fred Singer will say, I'm not 100% sure it's not humans. And if you're not 100% sure it's not humans, then there's a reason to begin to start to try to think about what the hedging should look like against what if it is the fact that it's human beings. The second point is a fundamental word, and what I identified as the most important conclusion of the fourth assessment report is that it's iterative, means that we're going to learn over time. Some things we've proven that we won't learn in a timely fashion. We will not quantify climate sensitivity in a timely fashion. We're just going to have to live with that. But other sorts of things, like maybe understanding the ice sheets a little bit better, what's going on with cloth rates or this or that, what's going on with clouds and how to build those in better, whether or not we can make some reasonable associations between climate change, warming, surface temperature in the oceans, and coastal storms and hurricanes, those sorts of things. Who knows? So some of the people that you mentioned, I would agree with you, participate honestly and openly. Some of my friends don't think much of Fred Singer, but I've known him for a long time, and I like him very much. And he puts the likelihood that it's not humans at 95%. So he and I can then have a conversation, well, what are you going to do with the other 5? Some of them I take objection to. I wouldn't believe what Michael Crichton says about climate. He is a cherry picker. And given the insincerity of the public statements of John Christie, I wouldn't believe him either. He contradicts himself in his own published stuff on 2020 with John Stossel when he was there, just to get on TV. And I don't think that's an honest way to play this game.
It feels to me that this highly inflated term of ClimateGate consists of two parts. There was the initial hacking into the personal email of a bunch of scientists, and that was later followed by the discovery that there were errors in the IPCC report. I think this whole thing about the melting of the glaciers, if it was 2035 or 2350, is simply a simple typing error. There was a reviewer who noted it. It got noted by the writer. In the end, it didn't make it right into the final thing. In that same section, there's a much bigger error about the surface area of the Himalayan glaciers that nobody mentions. There's a factor of 10 off. And so, yeah, every newspaper, including the New York Times, publishes every day corrections to the errors made in yesterday's newspaper. And so, yeah, when publications are made, there are a little slip-ups, and that doesn't mean that there's malintent. I think the hacking into the personal emails is a whole different story. That way you look into the process of how the scientific process works. And two examples I remember from reading all this. One was that the guy asked Bill Jones, did you look at the 1956 winter temperature data? And he answered, well, at the moment, I don't know where I have this data, but I'll look it up. And somebody says, they don't even know where they got their data. Well, every scientist knows that they got some file here, some file there, yeah. That's the nature of science. And you really find back what we got. That was never intended to go to the public, and was not published as such. So that was kind of glimpsing into the way science works and then shedding that light on it. The darker thing is that there was said, and this goes back to the hockey stick model and the nature of the medieval warm period, that Jones said, well, let's not talk too much about the medieval warm period because all those loonies start tracking again at it, and we simply don't understand what caused the medieval warm period. And we only get all this shit around the fen from people say, oh, you don't understand it, let's keep it quiet. That is indeed something that would concern me as a scientist. It's not talking about something that you don't understand. You got to be honest about that. And so I think these are the different dimensions of ClimateGate. One, kind of peeking secretly into personal email, which shouldn't be clipped in, and then giving your opinion from, oh, they don't know why they have the data. A little bit darker is indeed saying from, well, we're not going to talk about the things that we don't understand, because then all the loonies come out and we're standing in our underpants. So that's my view here. That we don't understand all the things like this. I mean, there's overwhelming evidence that the glaciers are retreating. Lonnie Thompson's work, that we don't understand the process of them. Suzanne gave a beautiful overview of the various aspects of glacier melting, like the earth, the grading in temperature, and hence sublimation. That they are retreating, we know for sure, from all the photographs of the last 100 years at almost every glacier in the world. The glacier I go every year in the Andes is a few tens of meters further away. And that's the cumulative evidence that everyone has. So I'm not sure who I'm addressing to.
But I think it speaks to this issue of how we know we have global environmental problems, and I think we as individuals can figure out for ourselves to a large extent how this thing works. I mean I think back 100 years when Arrhenius did his first calculation of what a doubling of CO2 in the atmosphere would bring on in terms of temperature warming. It was just short calculation. It's still just about right. I mean, he was interested at the time in global cooling because he was interested in glaciology. He was interested in a very different set of questions. But people have been writing about the possibility of anthropogenic climate change for a very long time. It appears in science textbooks back at the turn of the century. And there are a lot of ways that we as ordinary people, without access to fancy climate models, could figure out that warming is happening, that's a real thing. And moreover, I think in some ways the fancy climate models even make the problem worse because they provide such a fertile ground for misunderstanding and abuse of innocent mistakes. Anyway.
Arrhenius numbers is pretty close to the middle of the quoted 80% confidence range for climate sensitivity. He did, however, think that warming would be benign, actually beneficial. He's from Sweden, so I guess. Phil Jones said, hide that stuff. Michael Mann didn't agree to do that. So the inventor of the hockey stick did not back away from it.
And this story that more of Holland was below sea level than quoted. As you know, we are putting more and more dikes about land that is currently under sea level. So indeed, the amount of Holland that it will be under sea level is growing by the day because of all the land incorporation now, which is currently below sea level.
But you've been doing that for centuries.
We've done that for centuries. So the percentage of land in Holland that is below sea level is growing radically because of all the dikes that we built.
So there's a growing industry in Florida that you can attend to once you're done with the Netherlands.
Well, as the moderator, I'd like to make just one last comment, which is actually drawing on a number of things that our speakers have said. One is, and this goes back to the comment about skepticism, and one of the things I think we know very well about the science of climate change is this coming from somebody who's a philosopher who spends a lot of time thinking about modeling and theoretical models in the sciences. And that is, and this was a point that Suzanne was also making, that we have a much better understanding of the causal processes involved in the climate system. That's really been a dramatic improvement over that. Then we have confidence in specific predictions, but that causal dynamics is very well understood. There are a lot of very detailed data going back now to the reconstruction of climate history, which is an enormously solid understanding. And you can leave the predictions and with a fair amount of uncertainty, as the IPCC does, and still be very worried, which was a point, again, Gary's point as well, that the issue is not what do we actually know is going to happen, but what should we be worried about and what should we be taking reasonable steps to foreclose. And finally, a point that I would draw from Paul's comments, we've had a great deal of discussion of the science, of the controversy, of the process of forging a reasonable policy consensus. We have not had much discussion tonight of the political process of actually building an international consensus on actions to take that might be sensible actions in response, and an effort to assess how good our practices are at matching our political will and our capacities for cooperation to whatever reasonable policy consensus we arrive at, which again has a range of disagreement. But I don't think anyone thinks that we have gotten our policy implementation process at the level of any of the other processes that we've been talking about. And that will have to be an issue for another occasion.